Hey everybody, John Grimsmo here, bringing you another Saga Saturday, and today I'm going to show you guys our Nakamura lathe and some of the parts that it makes for our Saga pens every single day. So this is a CNC lathe, and this is a Pierre. He's going to be helping us explain this machine today. So this CNC machine costs a couple $100,000, and we've had it since 2016. It's the second big boy machine we got, finally fully paid off, all ours now, and as much as I might kind of complain about it on our Business of Machining podcast a little bit, we actually really do love it, and we run this machine every single day. It's been one of our most reliable, consistent machines for the past so many years, 8 years, 6 years, whatever, and it's just solid. Could you explain to us what a CNC lathe is and what it does? Because actually, this is perfect timing. Look. Turn around. He is wearing the perfect shirt.
Yeah.
So, tell us, my friend.
CNC lathe. So, for those who know what a lathe is, I don't know if I need to explain what CNC means, but a lathe is going to pretty much allow you to make round parts. How to compare a lathe and a mill? I don't know if you talked about that already.
Yeah.
No? Okay. A lathe has usually the part turning and the tool being advanced into the part,
Okay.
where a mill usually has a tool turning and fed into a fixed position part. It's a very brief, resume, but that's about it. And CNC just means computer numerical control,
Yep.
which just means that instead of me turning by hand some, adjustments, the computer does and decides what number should be called right now. So you see the numbers move here. Those numbers are positions that on a manual lathe I would have to turn handles to bring to a dimension. This does it fairly reliably and automatically, so we can reproduce the same part over and over and over again without needing to redial everything every time.
Yeah, so when you went to school for this.
Yep.
And you learned manual machining, and
Yes.
you turn the hand cranks and watch the readout or even just the indices on the thingy.
Yeah.
And my first lathe that I ever touched was a manual lathe as well, 1940s war era kind of machine. And the cool thing with CNC, like you said, is you program a code and it will execute the same motion every single time.
With some variation.
With like tool wear and thermal and things like that.
Yep.
But that gives us the consistency to make a product over and over and over and over again.
Yep.
And that's what we do now.
Yeah, I mean, by all intentions, it still needs a person to check it, because like you said, thermal growth of the machine is a real thing. Tool wear is a real thing, even in easier materials like we're cutting now, copper. Things are gonna wear, and 1/1000th of an inch is enough for us to be outside of tolerance, and parts won't fit anymore. So
Yep.
yeah.
And I mean, 1/1000th of an inch is 0.001 of an inch. You take an inch and you cut it up 1,000 times, or you cut it up 10,000 times to where we also measure to tenths. It's a lot of numbers.
Yep.
But everything, I mean, we see in the Saga pen specifically, tolerance stack up is a really big thing. Because
Absolutely.
this dimension plus this dimension plus this dimension plus this dimension equals a pen that no go.
Yeah, I mean, especially for our clip here, which is kind of a special part, I would say, which is not a typical lathe part, but every tolerance is important. The fact that this side is as tall as this side is really critical for the positioning of the clip when it's on the tube, and that's something that you can't even really see if you don't use the specific right measuring tools to detect that, because otherwise it just looks good.
Yeah, parts come off, they look fine if you don't measure them, if you don't know what to measure. And since, I mean, we've been making this for 6 years now, but certainly in the beginning, invent a part, invent a process, and then you add measurements as you go to figure out what to do.
And even years into the process, like every time I set up a part on one of the machines, we usually find something that we can refine, improve, make more reliable or easier on the operator or easier on the QC. There's always a way to improve.
Yeah. We just missed a cool part ejection here. I'll try to get the next one.
So we face the end of the bar, then we do a pre-drill with a short drill that you see underneath right now.
Okay.
Then the long drill is gonna drill the whole length of the tube. This is a very delicate installation for that tool because it is so long that the slightest misalignment can be catastrophic.
Yeah, it's still going.
Yep.
Just about to come out. There it goes. Sorry about the focus. It's really hard through all this coolant.
Okay. Now we have a probing that will actually detect if we broke the drill inside the tube.
Okay, so it's just confirming if there's a hole.
Yep. Yep. Or if it didn't get drilled for some reason. Now we're cutting the beauty groove, as we call it.
You're the only one that calls it that, but I like it. I like it.
Yeah. And now we're on the inside diameter, turning the bore for the threads with the same tool.
Can you show me a tube?
Sure. So,
okay.
Here, I don't know if you see really that groove now.
Tip it towards me a bit. Oh yeah, the groove, don't worry about it. So inside you're cutting a diameter for the threads.
Yep, with that chamfer that you see inside is also really important.
Yep.
We cut the inside, the root diameter of threads, and with the same tool, turn the threads.
So the drilled hole, and then you make the hole a little bit bigger for the threads.
Yep.
And then you're threading it with a single point thread. Okay.
After the threads.
The sub spindle just came in and grabbed onto the part once. I wish I could. I'll try to get the next one. Okay, maybe we have another clip. But once it's on the sub side,
we face again, turn that groove again, and then inside turning.
And you're doing the same thing. You're turning the inside, you're threading the inside, facing it again, and then it ejects the part.
Yeah, I mean, the tube is symmetrical for us. So we basically do a bunch of operations on the main side, then transfer it to the sub side, and do those same operations with opposite tools on the opposite side. Yeah. And we do the groove, and we do the threads, and it's gonna eject soon.
Here's the threading operation. Single point threading. And everything is, in a threading op, everything is synced very well. Here we go. It just pukes it out. There we go. And it continues. Now he's blowing out the part. He's going to visually inspect it. Measure what needs to be measured. And these are copper, right?
Yep. They're tellurium copper.
Yep. So pure copper is like machining hard bubble gum. It's not very fun. But this tellurium copper has some extra goodies inside to make it more machinable and still have relatively the same properties as pure copper. So now he's got a thread gauge and he's checking that the thread goes on the go side of the thread gauge, but not on the no-go side. That could be a whole video right there, just how thread gauges work. Excellent. Now he's doing a visual inspection for scratches or dings or dents.
There's a small ding here, but it might get lifted in sanding.
And then they go on the rack for further cleaning. Sanding, polishing, anodizing, not copper, but other parts. So on this machine, if you wanted to make many parts, you go memory restart. If you wanted to make just one part, you go memory. So walking around this thing, it has a chip conveyor. So it's a big conveyor belt. All the chips get dumped into here. Right now, Pierre is trying to separate some copper chips for a personal project. And it's got a big external coolant tank here with a 300 PSI coolant pump. and a canister filter. We have an aquarium bubbler that when we turn it on just adds a little bit of bubbling of air pressure to the tank. There you go. And what that does is if the machine's off for the weekend, it adds a bit of aeration to the coolant so the coolant doesn't grow bacteria and get stinky and go stale. And that seems to work really good for a $50 pump. And then behind the panel here, you can see the machine move around. Right now it's not, but it will. So this is where you can take the panel off and access. We usually don't have to, but we go in there, we clean, we make sure everything's still good, we make sure none of the hoses are loose. And there you can see the axis move. And then we've got a Aerox mist collector, which that tube goes all the way to the machining enclosure and it sucks all the mist and the jungle inside and goes through a HEPA filter and makes clean air. And the filter was last changed just in April, so that's good. Let's take a look inside this thing. So one of the cool things with this machine, as opposed to many other lathes, this is a dual spindle lathe. So it's got an identical spindle on the main side, like every lathe, and then it's got a sub spindle over here. So this has a collet in it, identical to that one. So this can open up, come in, clamp onto your part. You can cut it off, or you can pull the part out, or you can do all kinds of things. Once you pull it out, then it brings it back over here. And then notice how we have tools on the main side and we have tools on the sub side. And the turret here goes all the way around and has multiple different positions. We got our drills, we got our turning tools all the way around. Probe, drill, internal boring bar, and we have other tools on this side. And you can configure these blocks, you can rotate them around. So if you're doing a weird setup with the new part, you can do that. Pierre's gonna rotate the tool changer right now. I noticed he's got to push the two-hand button so that he doesn't crush his fingers inside the door. And this is super slow speed. When the door's closed and it's machining, it rotates like this fast. It just flies. And then you've also got axial end mills and drills and whatever you need. Super capable, super amazing machine. For the most part, it's hilarious how this machine is so big and can machine a 6-inch puck, and we're machining these tiny little things. But it does do the job. And we have the pill bottle, which we haven't used in years. When we used to make the little knife screws, we needed a place to eject them because they're so tiny that they don't really fit in the basket, they fall through the holes. So we used to have the pill bottle come down to here, and then it would just eject it into the pill bottle. So when we came in the morning, there was 300 screws in the pill bottle, and it was just awesome. And I can't believe this thing has literally held up since 2016. 7 years ago. It's awesome. Yeah, there you can see the conveyor on the bottom conveying chips. So that belt goes all the way under and goes all the way that way. So over the years, we've used the Nakamura for a lot of different parts. It used to be our only lathe, so we'd make, you know, for the knives, we would make every single screw, we'd make the pivot, we'd make the bearing cages, and then we developed the pen on this machine too. So we used to make every single pen component, literally the entire pen on this lathe until we got the Tornos, and then we've been making probably half the parts on the Tornos and half the parts on the Nakamura. So for the past 2-3 years, the Nakamura has only made 3 components every day, non-stop. We switch between the components week by week kind of thing. So it's making the tubes, which it's making right now, and we just talked about that. It also makes the slider of the pen. So that's the little release mechanism. Goes there. We will make this out of titanium or copper, no, just titanium or bronze. We won't make this out of copper, copper's too soft. The tube and the tip can be copper, but nothing else can. And then we also make the pocket clip, and we only make the pocket clip out of titanium. It just kind of sucks in every other material. You need the springiness and you need the durability of titanium to do that. So those three components, day in, day out, that's all this machine makes, and it's reliable, it's great, does the job. I mean, the clip is a really complicated part with a lot of milling. We'll do a whole nother video on that someday, but back when Pierre's set up for the clips and making those. But yeah, thought it'd be fun to get a little rundown of our baby. And then actually some of those parts, the clip and maybe even the slider, eventually want to put on 1, 2, 3 lathe, on our third lathe, the Williman, which is a whole different animal. I want to put the clip on here for sure, and maybe some other parts, but I'm not quite there yet. So there you go. That was some lathe insight, because yesterday I was wearing my I Love Lathes t-shirt, not today. But don't forget to subscribe, because I'm catching up to this guy, bit by bit, we're catching up. That's about it. The Nakamura's been awesome. Alright guys, thank you so much for watching, and I will see you next time.